Hey there, favorite class. Hope you're having a great digital day. Hope you're learning a lot and hope it is productive. Today I want to teach you everything you've ever learned and felt about area. So you probably don't have your math notebook with you. If you do, make this the title on the next free page in your math notebook. If you don't, make this the title on a piece of paper that tomorrow you'll put into your math notebook so you don't lose it because you're going to have some very valuable stuff on here. Uh, and then after that, going to be quite an I do today. So put that all aside, empty those hands, turn off any distractions around you, and concentrate till we get to we. All right, so start with me. I'm going to teach you everything you've ever learned about area super fast. Third grade. Think back to third grade. Remember yourself in third grade? You were probably cute and adorable and totally different than you are now. Those were the days, right? And in third grade, you had a teacher who taught you about area, and they taught you that area is how much space is inside of a figure. And you probably only dealt with rectangles in third grade. And we did something like this. We said, I wonder how many 1 inch by 1 inch squares we can use to measure this. And you said, well, if this side is 3 squares, 1, 2, 3, and if this side is 5 squares, 1, 2, 3, 4, 5, then look, all these 1 by 1 squares, we can count them. This is called tiling. And you did this in third grade and you figured some great things out and you figured out, oh, there are 15 1-inch squares in the rectangle. And that's what you learned about area first. And then you went to fourth grade. And in fourth grade, your teacher said, hey, check it out. There's kind of a pattern here. We did this one. If you tile this the third grade way, you'll notice there's 15 squares in here. And a shortcut, which we're going to call a formula, which became really nice, is you could say, hey, I know there's going to be 15 squares in here because there's going to be 5 squares this way when I draw it, 5, and there's going to be 3 squares this way when I draw it. And so instead of drawing and counting all those squares, I can just predict that there's going to be 5 by 3. Now I know how to multiply, and I can use this formula that the area of a rectangle rather, is equal to the length of its base times its height. So in this case, its base is 5 and its height is 3. So this one would have 15 square inches in it. I said, hey, that's nice because now if I got a new one like this, I could tile it. I could go ahead and do 1, 2, 3, 4 here and 1, 2, 3, 4, 5, 6, 7, 8 in there, but I don't really want to, and I don't really need to because I know there's going to be 9 going this way and there's going to be 4 going this way. And now I'm in fourth grade and I'm good at multiplying, so I can use that formula and just kind of shortcut it and say, hey, the area is going to be equal to its base times its height, and its base is 9 and its height is 4 and its area is 36. And you were like, oh, yay, that's nice. And not only is that nice, it's real nice because there's sometimes going to be ones like this that I don't even want to tile because, oh my gosh, this would take me forever. Lucky me, I have this formula. I know if I did this, there would be 32 this way and there would be 20 this way. And I can just use that formula that the area of a rectangle is equal to its base times its height. And now I don't get into all that clumsy tiling. And you were like, oh, cool, yay. Then you went to fifth grade. And in fifth grade, you didn't talk about area. You did probably talk about volume, which is sort of like the 3D equivalent of area. 2D figures, flat figures have area. 3D figures called prisms have volume. And you learned, hey, just like I can tile a figure to find its area, I can fill a prism up with cubes and find its volume, but that's not area. So then you went to sixth grade, and in sixth grade, there were shapes other than rectangles that you had to find the area of. And I asked you to find the area of something like this, or like this, that was called a parallelogram first. And you said, uh-oh, that's impossible, because look, I can't count the tiles, because look at that one, and look at that one, and I've got all these pieces, and I don't, and even this teeny one, and I don't know what they were like. And so you panicked, and you were like, oh my gosh, it's impossible. And I said, hey, chill, it's okay, you can do it. Check this out. There's this thing you can do with a parallelogram. Watch what happens. You can cut it and move it around, and if you cut this parallelogram like this, and you move this piece over there, then look what you've got. You've got a rectangle. And we moved that over there, and you've got a rectangle, and we're like, oh, sweet, because I already know the formula for the area of a rectangle is its base times its height, and if all I have to do is move stuff around and make a parallelogram into a rectangle, then guess what? The area of a parallelogram is also equal to its base times its height. And you were all like, wait a minute, does that work all the time? And I was all like, yeah, because look, even this one, you just move this over here and look what you got. You got a rectangle. So if you know the base and you know the height, you know that the area of a parallelogram is the same formula as the area of a rectangle because you can always turn a parallelogram into a rectangle. And you were like, cool, that's not that bad after all. I shouldn't have panicked so much. So then we moved on to triangles and you were like, oh no, panic again. And I told you to chill out because guess what happens? Triangles, there's a way to do it too. Even though they have these pesky little partial things, you can still do some maneuvering and tile this, but it's different than a parallelogram. Parallelogram, you cut part of it off and moved it somewhere else. That doesn't work with a triangle, or doesn't help at least. But what you can do is say, hey, look, I'm going to take this exact same triangle. I'm going to flip it and move it over there. And look, there's 1, 2 of the same triangle, and look what I made. I made a rectangle, and I know how to find the area of a rectangle. So guess what? I can also find the area of a triangle. Very similarly, I can say, oh, look, I can turn it into a rectangle if there's 2 of them. So the same thing, I can take the rectangle formula, base times height, because now I've got that, except it's only half of that, because only half of that was my original triangle. So I can just take that base times height formula and divide it by 2, or more often you'll see math teachers say base times height, and they'll multiply it by 1/2, but either one works. You double it. Say, okay, well, that's great, Dr. Dilbert, but that's a right triangle, and right triangles are easy to turn into rectangles. And like, what about this one? Like, I can't turn that into a rectangle because it's not a right triangle. And I said, hey, still don't worry about it because look what you can do. Same thing. If you double this and flip it over there, you end up with something kind of like that. Those are the same triangle 2 times, and look what you've got. You've made a new shape. You've made a parallelogram. And guess what? Do you know the formula for a parallelogram? You do, because we already did that earlier the same week. Said, oh yeah, remember the area of a parallelogram is base times height, because you can turn a parallelogram into a rectangle. So any triangle, even if you can't turn it into a rectangle, you can turn it into a parallelogram. All you have to do is remember that after you find the area of that parallelogram, you have to divide it by 2, or multiply it by 1/2 so that you only get the part you wanted, not this whole thing. You're like, huh, cool, not that bad. So we also looked at shapes like trapezoids, and you were like, okay, I'm drawing the line here. There's no way you can do this. And I was like, oh yeah, you totally can. There's actually a couple ways. Like, one way you can do it is you can do that doubling thing again. And if I draw it just right, like, look what you're going to have after you double it. You're going to have a parallelogram. And you were like, ugh, hate when you write all the time, because that's what you sound like in 6th grade. You don't like when your teachers write. But, or you can do this thing called decomposing it, like this. And you were like, wait a minute, I know what decomposing is. That's when a dead thing like totally rots. And I was like, no, that's science. And in science and math, we use the words in different ways. So you can decompose it in math into a rectangle, which you know how to find the area of, and into 2 triangles, which you know how to find the area of. So you can find the area of that too, as long as you don't panic and just like give up real fast. And you were like, fine. And you did it, and you did pretty great. And that was the end of 6th grade. And now we're here. So review time. Grab that sheet of paper or open that math notebook, and let's do a fast review of these things that you have learned in the past so that you remember them as we move into the future, when they will become important, and we will build off them some more. So first thing I want you to write down and know: 1, area can be calculated by tiling, which is that original strategy you learned about in 3rd grade, and we did it a lot in 6th grade before we learned the formulas. Tiling always works, but it is a lot of work, and you're lazy, so you don't like to do it. Write that one down first. Here's a couple examples of why it's easy, but why it's also a lot of work. And I don't want you to ever forget that this happens. Formulas are hard to remember, and there may be times when you forget formulas. And I don't want you to panic and freak out and think that, uh-oh, I forgot the formula. There's no way to possibly do it. There is. You can always do this stuff where you cut and move and do that if you need to. So stop and write this now. Unpause when you're ready. After tiling, area can also be calculated using formulas. Formulas are nice because they're short and important to remember. The formulas, they don't need an apostrophe there, come from the tiling strategies. The formulas aren't just magic things some math teacher made up. They come from the exact things you do in the tiling strategies, where you cut and move and double and all that stuff. So write this down as number 2. Also start yourself like a chart here, because we're going to review real quick what polygon has what formula and why that formula works. Okay, let's start with rectangles, number 1 on your chart. So rectangles, like this one, I'm going to move the actual picture over here. I don't need you to draw it there. Rectangles, their formula for area is that the area of a rectangle, I like to write it like this, like rectangle here, so I know what I'm talking about, is the length of their base times their height. The reason that formula works is it is just like a multiplication array that you learned in 3rd grade. So that's the first one, right? If we were to tile a rectangle that is 3 by 6, we end up just making a 6 by 3 multiplication array, and that's why that formula works. It's not magic. Some math teacher didn't just come up with that and say, hey, just do this, trust me. It came from somewhere. It came from this tiling strategy that you learned in 3rd grade. So start your table here and fill out those 3 and unpause when you're ready and go to the next. I'll go to the next slide. So rectangles number 1, let's move to parallelograms next. Parallelograms, remember, before you start writing, parallelograms are the one where you can cut one end of it off, move it over there, and then you end up with a rectangle. So you can take any parallelogram in the world and you can turn it into a rectangle, which is nice because you already know the formula for a rectangle is the rectangle's base times its height. And if you can turn a parallelogram into a rectangle, guess what? Same formula. Area of a rectangle is its base times its height. One thing to remember, the height goes from the bottom to the top. So that's the height here. This is not the height, not this slant. That's not how you measure how tall something is. That's just a thing to remember. I'm going to move this out of the way now so we can talk about why it works. The reason that formula works, again, it's not just some math teacher voodoo magic. It is logical because that reason that formula works is you can turn, I'm going to say can turn, any parallelogram into a rectangle, which has the same formula. So that's why that formula works. So pause now, or draw yourself an example if you want, at least fill out your chart if you don't, parallelogram formula, reason why it works. Last one, triangles. We also learned, we did right triangles, we did not right triangles. Triangles are the harder one to remember because they have a similar but not the same formula. Remember, a triangle you can turn into a parallelogram, and a parallelogram you can turn into a rectangle. But you've got to remember when you make a triangle into a parallelogram, you make 2 copies of it. So you can use the parallelogram formula because it's the same. You've just got to remember to divide it by 2 after you do that. And then again, I'm going to move that out of the way so I have room to write the formula and why it works. So for a triangle, the formula is area of a triangle equals, I use base times height divided by 2. Often your math teachers will use area of a triangle is 1/2 times the base times the height. They multiply by 1/2 more often than dividing by 2. Same thing, either one totally works just fine. The reason that works is you can double any triangle into a parallelogram. So pause here, write that down, and we are almost to the end. So that's what you've learned up through 6th grade. So what about 7th grade? Why am I reviewing all this? Who cares? It's not 6th grade anymore, or 3rd grade, or any of those other things. Why do I care? Well, we're back to area starting tomorrow. And in 7th grade, you learn how to find the area of a circle. Oh no. Real bad, right? Because if you look at a circle, this is going to be awful because not only do some of the squares get cut off, but they're rounded. And how in the world, if it's rounded like that, are we possibly going to figure out what portion of a square we have made? So if you want to add this, we're going to finish this tomorrow. Add on your chart circle, which is totally not a polygon, by the way. We're just going to put it there. Polygons have to have round sides, and we'll work starting tomorrow on its formula if it has one and why it works if it does. That is everything you have ever learned about area in under 15 minutes. 3, 2, 1.